Okay, so the fourth lesson is about the logic gates with Boolean functions. So first of all, you need to understand why we are learning this kind of a lesson, right? It is because this lesson describes you what kind of a circuit arrangement or like what kind of an arrangement happens inside these physical components. Like basically when it comes to the circuits, how the circuits are working inside the computer, right? Specifically, they are going to talk about the central processing unit and other ICs that you are going to see on a motherboard, right? So here they have given a very nice picture to have the abstract idea about why we are learning the gates, right? So CPU is made out of a particular circuit which contains a lot of these copper metals and all these things, right? So all the connections are there, right? So like these connections will make or will produce several logics, or like it will help to process things. Now, if you think about a CPU or a particular IC, these are some real pictures about the ICs. So like in outer shape, it is something like this that you can see on your right hand side, right? It is something like this. And if you think about the inside of a IC, it's going to be like this, right? So first of all, remember, when you dismantle or decompose a particular integrated circuit or a particular CPU, you will be able to see a circuit something like this inside there, right? And it is a collection of a lot of copper wires and the copper conductors, right? And some metal parts that have been used for the CPU circuit. And you won't see any particular or like a very clear diagram inside it, right? Or a clear arrangement inside it, right? But the case is we won't be able to recognize or to learn the things that is happening inside a circuit just by drawing a picture like this, right? Which is not possible, right? So අපි මේ වගේ මේ wires handla ඉගෙන ගන්න ගියොත් it's not a it is something hard to learn and hard to understand, as well as we can't get a clear idea about this. So because of that, as you can remember, when you learn about the electricity for the science, you have used different kinds of symbols, different kinds of methods to show the circuits, right? So as an example, you have used several different symbols to indicate a bulb, to indicate a resistor, to indicate a capacitor, to indicate a battery, right? So likewise, when it comes to the computing, we have logic gates to indicate what's happened inside a circuit, right? So logic gates will give us a clear idea or help us to have a clear idea what is going on inside a circuit. So for that purpose, we are learning the lesson which we call the logic gates, right? So as you can see here, it has decomposed into the several different new words. These words represents the gates, and those gates, the circuitry part represents like this, right? These are some electrical components, right? But when it comes to the diagramming, or like when it comes to the logic gate lesson, we are not going to draw these kind of circuits in this manner. Apart from that, or other than that, instead of that, we are going to learn certain symbols to represent gates. Some symbols like this, right? You will get to know what kind of a symbol are these and what are the purpose of these things, right? So you will be learning symbols, something like this, which helps you to identify how uh, the operation, the logical operation is going on with the CPU when it comes to the computer. Right. So with that idea, let's look into the lesson. What are the things that we need to learn? And when it comes to the logic gates area, we call this the Boolean sector, right? So Boolean sector contains Boolean logic gates, Boolean algebra, several different kinds, which is regarding the Boolean, right? Boolean means it's a programmatical word which indicates true or false. That is what we call about the Boolean values, right? When it comes to the Boolean sector, we are talking about the true and the false situation. So we consider one particular states. So either the true state can be considered as 1 for the computer and the false state considered as the 0, the computer, right? Why we are mapping that ones and zeros to the true and false? Because the computer can understand the things as ones and zeros, as we learned in the previous lesson, right? So when it comes to the Boolean algebra or like the Boolean sector, when we are working with the gates, we are working with ones and zeros again, right? So in when it like in the gate sector, we map these one into either to a true or to a false, right? That is according to the scenario that we are going to learn or that we are going to tackle, right? However, it will describe the things by using two states, right? A one state for the to indicate 1 and another state to indicate a 0. Right? So in the journey of understanding the circuitry inside a IC or a CPU, we have to learn about these symbols which represents the gates, and we have to learn about the operations which is done by the gates, right? So to understand that, first of all, we have to identify what kind of gates that we are having, right? So there are two types of gates, two categories. One type is the basic logic gates, as you can see here. So in your syllabus, you are introduced with 3. Actually, there are 4 gates, right? But you are given with only 3. And then the combinational logic gates are introduced. So the combinational word will give you the sense it is kind of a combining process which is happening over here. So combinational logic gates, in your syllabus, you are going to introduce with 2, but actually there are 3, right? So these additional things you will be able to learn if you are doing the ICT for your A-levels. So here we are going to learn about 3 basic input, 3 basic logic gates and 2 combinational logic gates. Right? So let's see what these things are. In your book, they have done an introduction. So we'll come to this point. So these are the 3 basic logic gates that we are going to learn: AND, OR, and NOT. Right? So they have some funny names, but we have to know how these things are working to recognize or to understand how a IC is going to work. All right, so let's write the main heading as a start, people. So everyone, please copy the main heading. It's your 4th unit, logic gates with Boolean functions. All right, if you are done with that, let's take down the things that we have to take down regarding the logic gates, right? So I will summarize these things over here so you can write it later, right? So when it comes to the logic gates, there are two types as we learn. The first type is called the basic logic gates. The second one is called the combinational logic gates. So there will be basic logic gates, then the combinational. Right, so under the basic logic gates, as you saw, there are three types. What were the three types? There was something called NOT gate. And there is something called AND gate. And there is something called OR gate. Right? So in the symbol wise, we can indicate NOT gate like this, a triangle and a small circle, and these lines are there. Right, when it comes to the AND gate, the word AND ends with a capital D. So you can remember like AND gate is kind of a capital D. This is the way. And OR gate is like a crescent. Right, so these type of symbols are there to indicate the basic logic gates. And in the context of the combinational logic gate, we got two of them. Right, so one is called NAND gate, and the other one is called NOR gate. Right, so NAND gate, this is something very familiar to you. So like it's the same AND gate, but it has a circle in front of it. And NOR gate again, OR gate, but a circle in front of that. And there is a reason for that circle in front of the gate. So this is the way that the logic gates are being categorized. Okay, I want you to take this down to your books. So as the first note of the logic gates. So hurry up, people. Let me know when you are done. Okay, two are done. How about others?
No, sir.
Okay, let me know when you are done. Okay, anyone who is still writing? All right, so I'm moving forward. So let's talk about the basic logic gates first, right? There are more to learn regarding the basic logic gates. So when it comes to the basic logic gates, we learned that there are three types. Right, so the first one is the NOT gate. Right? So how the NOT gates are going to go? And we learn that the NOT gate symbol is something like this. So what are these lines? These lines are indicating the inputs and the outputs. So the left-hand side, we have inputs, and the right-hand side, we have outputs. Right? And when it comes to the gate, this gate has a specific operation, right? Like when it comes to the electrical circuit, you know what's the purpose of a resistor, you know what's the purpose of the capacitor, likewise. So when it comes to the logic gates, NOT gate purpose, if it receives some Boolean value, that means if it receives a particular 1 or a 0, its purpose is making that received value into its opposite. We call that making the input, like inverting the input to take the output, right? So we indicate this in this manner. If A is given as an input, output is going to be, can be indicated as A bar, or we can indicate as A dash. Both the methods are being used, right? As well as to describe what's really happens with the NOT gate, there is a certain table which they call as truth table, which indicates the operation of the NOT gate. So in the truth table, you have a column for the inputs, and you have a column for the outputs. So in the NOT gate scenario, this is going to be our input column, and this is going to be our output column. So now, since we are talking about the computer deals with ones and zeros. So if this is a part of a circuit, this circuit, the input line can either receive a 0 or can receive 1, right? In two different scenarios. They are not going to receive 1 and 0 together at the same time, right? Either they are going to receive a 0 or they are going to receive a 1. So as the purpose of the NOT gate, I told you the NOT gate is there to convert the input. Yes, so. Yeah, sorry for that. And we can assume that the input line can receive 0 in one scenario, or else it can receive 1. So the nature of the NOT gate is whatever we receive, they are going to invert it to produce the output. Inverting means like making the opposite of it. So if the 0 is received, the output will produce your 1. If 1 is received, output is produced a 0. Right? So this is what you call the truth table. Right? So this is called the truth table. Right? So that is how the NOT gate works. People, is that clear?
Yes, sir.
Right, great. Okay, so the second gate, it is about the AND gate. Right, the AND gate. Right? So how the AND gate can be designed? I told you the word AND ends with a D. So AND gate is just like a capital D. And there is an output as well. So when it comes to the AND gate, we discussed that the AND gate is there to do a Boolean multiplication. A Boolean multiplication means once you receive A and B as the input, so since there are two inputs, we can take like there is A and there is B. Right? So that will be multiplied by the output, A dot B. Right? We indicate the multiplication like A dot B, and it is very similar to the mathematical multiplication, because when it comes to the Boolean sector and the mathematical sector, there are two different sectors. But here, the multiplication happens the very same way, right? So if you think about the truth table, it has A as the input, and it has another input called B. And we know A dot B indicates the output. So what can be there as the inputs? So there are two inputs. An AND gate, at least it should have two inputs, right? And it can have more, right? When it comes to the NOT gate, it's just one input, not less than that, not more than that, right? And always we have one output, right? So when it comes to the A and B, the inputs of the AND gate, we can argue it like this. When A receives a 0, B also can be received with a 0. When A receives a 0, there can be a 1 as the B's input. And when A receives a 1, B can receive a 0, as well as when A receives 1, B can receive a 1 as well. Right? So if you think about the input combinations, these four are the only combinations that we can think. There is nothing more than this. Since there are two inputs, if you are going to work with ones and zeros regarding the two inputs, so the combinations, there can be only four. Right? And I told you the Boolean multiplication goes very similar to the mathematical multiplication. So that means 0 into 0 will produce you a 0. 0 into 1 will produce you a 0 again. 1 into 0 will produce you a 0. 1 into 1 will produce you a 1. Right? So that is how the truth table happens in AND gate. People, is that clear?
Yes, sir.
Yeah. So again, I'm reminding you, AND gate is about a Boolean multiplication, about the multiplication, right? Okay, so the third one, which we haven't talked about, is the OR gate. Right? So OR gate, what's the nature of the OR gate? I told you it's kind of a crescent. And it has two inputs and an output. And these also take two inputs, which we can indicate as A and B. OR gate is doing a Boolean addition, which we can indicate as A plus B. Right? So even though the multiplication goes samely as the mathematical multiplication, Boolean multiplication goes as the mathematical multiplication, this does not goes like that. Right? We can say it is almost equal, but there is a very clear-cut difference in a one single situation. You will see when we are doing the truth table over here. So how the truth table is going to be planned? It's the same way, right? We have the input A, and we have input B, and the output is going to be A plus B. Right? And the input combinations goes the same way. 0, 0, 0, 1, 1, 0, and 1, 1. Right? And the addition. Look at this closely. So the first three additions, first three rows will go as the same way that we do the mathematical addition. So 0 plus 0 gives you a 0. 0 plus 1 will gives you a 1. 1 plus 0 will gives you a 1. Fourth one is the specialty. 1 plus 1 will not taken as a 1, taken as 2. 1 plus 1 will considered as 1. Right? The reason is, as I told you earlier, these ones and zeros, they are representing the Boolean values which you call true, this one as false. So here in the last line, it says, add a truth with another truth, which will give you a truth again. So that is why 1 plus 1 is given as 1. Right? So that is the way that the OR gate is going to work. People, is that clear?
Yes, sir.
Right. If you got any places to be cleared with, so it's time for you to ask the questions. Otherwise, we can draw this diagram onto your book. So basic logic gates. Okay, copy it to your book, people. If you got any questions, you can ask. Let me know when you are done.
Sir, AND gate කියන එක චුට්ටක් අර පැහැදිලි කරන්න. අර යට තියෙන එක A B A.B කියන එක අර මේ
එතන පුතේ තියෙන්නේ multiplication එකක්, right? එතකොට මේ inputs වල ඉන්න අය multiply වෙනවා. 0 into 0 0 0 into 1 0 1 into 0 0 1 into 1 1.
හරි සර් තේරුණා.
Right? Gayanija, at what part that you are asking to her?
O gate.
O gate. So O gate is doing an addition to her. So 0 plus 0 will give you a 0. 0 plus 1 will give you a 1, same as the mathematics. 1 plus 0 will give you a 1 again. Only this line is going to be the special. 1 plus 1, it is considered as a 1 though, right? It is because these 1 and 0 things, they are considered as the value of true and false. So 1 කියන එක සත්‍ය නම් සත්‍යයට සත්‍යයක් එකතු වුණාම අපි උත්තරේ අරගන්නේ තවත් සත්‍යයක් හැදුනා කියලා. ඒකයි 1 + 1 එකයි කියලා අපි අරගන්නේ. Got that dual?
Yes, sir. Thank you.
Right, okay. Okay, let me know when you are done, people. Right, two are done. How about others?
No, sir.
Right, okay, right, okay. Let me know when you're done. Okay, anyone who is still writing? Right, okay, Himsari, let me know when you're done.
Finish, sir.
Right, okay. Anyone who is still writing? Right, so let's go and see how the combinational gates are working. Right, so next we are going to discuss about the combinational gates. Right, so the first combinational gate that you are going to learn is the Nand gate. Right, so the Nand gate, how the Nand gates are going to happen. So the circuit or the symbol, first of all, I'll tell you how the Nand gate are being formed. So we take an AND gate. For the output of the AND gate, we fix a NOT gate in front of it. So that is how the NAND gate are being formed. But when you are drawing the circuit, you need to draw this symbol to indicate the NAND gate. Right? So what's happening here? You have given A and B. It will give you A dot B over here. And when it is being went through a NOT gate, it will give you A dot B bar over here. So according to this circuit, when A and B is provided, the output is going to be A dot B total bar. We call that the total bar. It goes on the entire term. And if you think about the truth table, the same inputs, A is there, B is there, and let's try to figure out A dot B bar at once, right? So the input combinations are going to be 0, 0, 0, 1, 1, 0, 1, and 1. And A dot B total bar, 0 into 0, 0 into 0, the answer is 0. Once it is been inverted, it's going to become 1. 0 into 1, the answer is 0. And once it is inverted, it's going to be a 1 again. 1 into 0, answer is 0. Once it is inverted, the answer is 1. 1 into 1, the answer is 1. And once it is inverted, it is going to be a 0. People, is that clear? Yes, everyone. Here what I have done is like multiplication as well as the inversion. We first multiply, then invert. People, is that clear?
Yes, sir.
Right. Okay. Okay, so the next one is called the NO gate. So the NO gate is made out of using an OR gate. We use an OR gate. And for the output of the OR gate, we fix a NOT gate in front of it. Right, so that means once A and B is provided, this will give you A plus B. And here you can find A plus B's total bar. And the final symbol, or like the NO gate single symbol, can be right like this. So A and B is going to give you A plus B's total bar. Right, and if you think about the truth table, one input is A, another input is B, and we are going to create A plus B's total bar. So how it's going to be? Input combinations, now we know it. It is familiar for us now. So what happens? It will add up, then invert. So let's add up. 0 plus 0, answer is 0. Once it is inverted, answer is 1. 0 plus 1, answer is 1. Once it is inverted, answer is 0. 1 plus 0, answer is 1. inverted, you get a 0. 1 plus 1, answer is 1. Invert it, you get a 0. So the output is going to be like that. Is that clear?
Yeah, sir.
Okay. So I want you to have your concentration of some special points in these gates as well before we move to that note. And when it comes to the AND gate, you can see when both the inputs are 1, then only you are going to receive a 1. And when it comes to the OR gate, when both the inputs are 0, then only you are going to receive a 0. Right? Those are some special situations. And if you think about the zeros of the AND gate, if you got a 0, at least a single 0, all your outputs are going to be a 0. If inside the AND operation, if you find 1 0 in between the AND operation, entire thing is going to become a 0. The opposite happens with the OR gate. If you find at least one inside the operation, your answer is going to become a 1. Right? And that goes oppositely over here. Right? So it's better you match. When you know the AND operation, you can easily derive the NAND operation. When you know the O operation, you can easily get the NO operation. Okay, so let's copy this down. This is about the combinational gates. Okay, let me know when you are done, people. And in case if you are not getting this, have the question, so I will help you. Okay, one is done. How about others?
Sir, no, sir.
Okay. Anyone else to be completed? Anyone who is still writing? Okay, right. So let's move forward. Now, let's sneak into your textbook and see whether we miss anything. So we talk about the logic gate introduction. And yes, here they have like illustrated the operation of the gates in an electrical way, right? They are trying to simulate the operation of the gates. Now here, what they are trying to simulate is the operation of the AND gate, the basic gate, AND gate. So how they are going to simulate it? So they take two switch circuit, which we are used to light up a bulb, and they take the open state of the switch as 0, is as 0, the closed state of the switch as 1. Now, we know according to the AND gate, you can watch it from, you can see it from your book, right? We have noted down. So if both the inputs are 0, your output is going to be a 0. So like close the bulb, or like not lighting the bulb will indicate 0. Lighting up the bulb will indicate 1. So in case if we are closing the switch, that means this 0 is going to become 1. But still, 1 and 0 will going to give you a 0. So that means this circuit is not completed, even though this is closed. This part is open. So the electricity cannot flow, right? Same goes with the other way around as well, right? So if you close the B, that means this becomes 1. If we keep open this, still the bulb is not going to light, right? So it will light up only in the scenario where both the switches are being closed, right? So in the same way, they have illustrated the OR gate as well. So they use this what we call the parallel method of the electric circuit, right? Right? So here what they have done, they have gone with the same argument, right? Lighting up the bulb will indicate 1. The bulb is not lighted up, it indicates 0. Switch is closed, indicate 1. Switch is open, indicate 0. Right? So if both the switches are being open, then the bulb is not going to light. In all other cases, bulb is going to light up. So like if B is closed, A is open, still the electricity can flow on this manner. So the circuit is completed, then your bulb is going to light up, right? And if you think the other way around, when A is closed and B is open, still A will help the electricity to flow to the bulb. So it will on. When both are closed, both will help. So the bulb is going to be light up again. Only in this scenario that the bulb is not going to light up. So it simulates how the OR gate is working. Right? Look at the way they have used to simulate the NOT gate. So they have used a trick over here, right? So they are using a resistor, right, and a bulb and a battery, and here there is a switch. When switch is open, electricity falls over the resistor, goes here, goes through the bulb and completes the circuit. That means when A is 0, bulb is going to light up. What's happened when A is 1? A is 1 means you are going to complete this part. Completing this will create a shortcut. We'll create a shortcut for the electricity to be flown. So it will goes over here and comes over here, and see that it has a shortcut and it gets short over here. So the bulb is not going to light up when the switch is on. People, are you clear with those circuits? These things are not be very much tested in your exam, but it's better you have the idea, the rough idea. Yes, people? Are you clear with that?
Clear, sir.
Right. Okay. Right. So you are always welcome to throw a question if you are not clear with the things. All right. So we get to know about the basic gates. We get to know about the combinational gates, right? And now we are going to do a small activity, right? So it's going to be like this. Now, when we know about the gates, we should be able to figure out what's going to be the output of a particular circuit, right? So, I'm sorry. To do this example, I will draw you a small circuit and I'll show you a small example. Then you can go with the questions that I'm going to show you, right? So I'll take an example over here. Obtain the output from the circuit given below. Right? So I'll take a small circuit where A and B goes through an AND gate. And there is someone called C as well, which flows here. Let's have a NOT gate in between. And flows through a O gate. Right? When I receive something like this, how I'm going to tackle the output? It's easy. If you got A as the input, you are going to receive A over here. If you have B as the input, you are going to receive B over here. So this is an AND gate. So this is going to provide you A dot B. It's better you have the brackets when you are getting an output from a particular circuit. So since you got C over here, you are going to receive C over here. So through the NOT gate, you are going to receive C bar. Now, C bar going to flow as a one input, and A dot B is going to flow as another input to the O gate. This is a O gate. Right? You don't need to color the gates like this, right? I'm just doing that for the explanation purpose. So this is an O gate. So O gate does what? It adds the things that it is being received. So what are things that it is being received? A dot B added up with C bar. Or you can say C bar plus A dot B. Right? Simple as that. Got that, people?
Yes, sir.
Yes, sir.
Right, great. So you can write down the example. Then I'll put you some questions. So you can try it later.
ඒකට
ඔබතේ
ඒක සර්
ආයි කියලා දෙනද? ඉතින් මට කියන එක
ඒක සර්
පැහැදිලි නෑ.
චුට්ටක් අය කියලා
right. ඉන්න.
නෝ
right. ඉන්න මම ආයි කියලා දෙන්න. right. මේ බලන්නකො මෙතන A තියෙනකොට AND gate එකේ එක line එකකට එන්නේ A. ආයි AND gate එකේ අනිත් line එකට එනවා B. දැන් මෙයා AND gate එකක් නිසා එයාගෙන් එළියට එන output එක අපිට කියන්න පුළුවන් A.B කියලා. ඒක පැහැදිලිද? හරි?
ඔව්
right. ඊළඟට අපි සාමාන්‍යයෙන් output එකට අකුරු දෙකක් ආවම එහෙම වරහන් දා ගන්නවා. ඒක
ඔව්
ඇඟට හොඳයි, right? ඊළඟට අපි බලනවා ඊළඟ input එක තියෙන්නේ C. C එනවා මේ not gate එක ගාවට. එයාගේ ඇතුලෙන් ගියාම C bar කියන එක තමයි output වෙන්නේ not gate එකෙන්. ඒතර ඒ C bar එක තමයි මෙතන තියෙන O gate එකට එක input එකක් වෙන්නේ. අනිත් input එක විදිහට එන්නේ A.B. අර AND gate එකෙන් output වෙච්ච කෙනා. O gate එකට තියෙන input line දෙකයි නේ කළු පාට line දෙක. දෙක line එකක එනවා C bar අනිත් line එකේ එනවා A.B. ඒක පැහැදිලිද?
ඔව් සර්
right. එතකොට O gate එක ඉන්නේ මොනා කරන්නද? එකතු කරන්න. එයා එකතු කරන්නේ එයාගේ lines දෙක එන දෙන්න නිකන් එකතු කරනවා. එතකොට එක line එක එනවා A.B. ඒක එක input එකක්. අනිත් line එකේ එනවා C bar. ඒක නිසා A.B ව C bar ට එකතු කරනවා. ඔක ලියනකොට අපිට මුලින් C bar ලියලා පස්සේ A.B ලියන්න පුළුවන්. නැත්නම් මුලින් A.B ලියලා පස්සේ C bar ලියන්න පුළුවන්. පැහැදිලි?
ඔව් සර්
right. හරි. දැන් අඳගන්න. මම මේ රවුන්ඩ් කරලා තියෙන දේවල් ටික මකනවා ළමයි මොකද ඒව ඔයගොල්ලෝ රවුන්ඩ් කරගන්න ඕනේ නැහැ. People, are we done?
Yes, sir.
Yes, sir.
Right. Anyone who is still writing? Okay. Right. I'm going to put you the questions. Give me a second. People, so write this question. My little one is with me, so you will be getting some noises. Okay. So write the question, obtain the output from the circuits given below. So I'm going to give you 4 circuits. So obtain the output from the circuits given below. It's the same question which I have written in the example. Only the instead of circuit, here you have to put circuits. Obtain the output from the circuits given below. Right, I'm going to show you the circuits. Right, so yeah, these are going to be the circuits. So you can draw these circuits and try to take the output out of these, which I'm going to discuss on next week when we meet again, right? So you can draw it and then you can exit the session, right? So I'm going to end the session from here and I will be staying until you all are leaving. So have the circuits onto your book and try to take the output. Right, so once you are done, you can leave, right? So thank you very much, everyone. Have a very nice day.